order differential equation with very short parameters, and I tried to explain this multiple times and I did not explain correctly. So this is going to be another long video. Over here, because we're doing the third order linear first time, I will give you the what you should try out, which is this thing, which will give you a auxiliary equation like that. Here's the auxiliary equation. I purposely chose good values to get a good coefficient. Good, and how I know it's true because I basically did went to Wolf Alpha and did parentheses x plus 2 parentheses square and got those coefficient and which was 1, 6, 12, and 8. And I put it into here to make my life easier because otherwise I would have to deal with an insane integral that I did not want to solve. Generally speaking, I was embarrassed. I'm not embarrassed, but it's kind of like there's no point. There's no learning from that. I don't think there is zero learning in it. So this has learning in it because you learn that the t above it is a t square, so you can imply the pattern is a t cubed, t fourth over here, so on. If they're a perfect cube, perfect. Oh, this is supposed to be a three. Why do I make these mistakes? I'll fix it later. I promise I'll fix it later. Oh, you know what? I'll fix it now. Oh my God. Why do I make these mistakes? Now I have to do it. The way I patch things is a little weird. You're gonna see how I patch it, which is what I do. I screenshot something like this, and then how I patch it, you're gonna be like, okay, that's interesting. I go over here and Control V it, and I make this. Oh, not that. Make this small like this, and then save it like this. Go over here. Yes. And do it like that. There you go. I made a mistake there. I fixed it. It's good now. Now it's even bolder, so it's good. Anyways, sorry about that. That was a mess up I did. Anyways, we have this thing, and then another learning thing you do is that they three have to be independent of each other because it's a third order situation, which means the particular solution is going to have three parts over here. Now, there's a human constraint over here that we're going to put in for very short parameters. You might think, well, that's arbitrary. Well, no, it's not, because you're going to force everything to conform to that. As you can see over here, we put that as our two conditions. So what's happening is our forcing the particular solution to get into that form. What that means is that these three must comply to that because we made it into our linear systems of to solve for these three. That's what we did. We forced this thing. So these oh, that's not supposed to happen. We're forcing those three to form to that form, like the last part over here. When we have this over here. So what does that do for us is that it makes our derivative easier because with the product rule we get a bunch of loose term, but I don't know who's the smart guy that thought of it. But if you make that into zero by adding those up and just constraining it into a like equation, we get a quite actually simple array of something like this is actually manageable, um, and so on for so forth. With that said, now we have two constraints. We can forge that into the plug back into original equation. Oh, you have to also get the third derivative over here, by the way. This is the long one that you can't really destroy because you only have two places because it's a 3 by 3 matrix if you do it by the matrix method. Anyways, this part, and this is why this question most people skip because it's not taught here either. I had to figure it out with Wolfram Alpha, and a lot of times they don't teach it because it is what's the word, bulky, but it gives you an interesting pattern in the end. I'll tell you the pattern, but it will give you the general form of the variation parameters for like higher order linear ODEs that you can use, and you can make a code that will solve it for you. Quite beautiful. And I'm not sure why I don't know teach it. Maybe it's useless. I don't know. But over here you get rid of this to get this form over here. And also they don't really teach you the proof over here. I'm doing the proof because I want to show the proof one time at least. Um I couldn't find a proof there, and I had to look at other stuff. And then I remember my class never taught the proof either, but I really like the proof, so I will be explaining the proof. Now, yes, so the proof allows you to get the final thing over here, this over here, and then we allow this to equal G because we is original the E that equals G basically. So this makes sense. You're getting everything. Um, yes. Over here we have this over here. And then we solve this by whatever method you want. Use a substitution. I rather just go to like a matrix and just put it into MATLAB, and they'll solve for you with symbols and everything. Your choice. I'm just telling you the best method, in my opinion. And then you realize it's a determinant here, and then at the bottom is a bigger determinant, and you realize a pattern over here, which actually gives you a bigger pattern over here. So if you go like a V4 over here, it's just adding a V4 over here with a different one over here, different one over here, different one over here. And then that's why I want to show this because the second order breaks that pattern a little bit. Um, so I wanted to do the third order to prove it all. And after that, it's just a bunch of what's the right word to pull it? A bunch of just algebra. You can see it. We have done this multiple times, so I shortcutted some of them. But you get this in the end, which, I was expecting a better like looking graph, but I can't complain about that. Because the ET is that, so it makes sense. Next up, we do a more, what's the right word? More, what's it again? Likely to happen in the homework. This is a more likely homework question compared to that one. That one's like, what the hell are you doing question. Um, and only done by lecture one time and you never touch it again. But even I don't think my professor never touched this because maybe this portion like third order and beyond that is useless. I don't know. But I don't know why they didn't teach that in my differential calculus class. But I know my book didn't teach it either. So sources to figure that out and it took forever. It might be because it's like too harsh. Like I can imagine this over here, like, oh my God, who wants to do this stuff? Like it doesn't make sense. Um anyways, we go beyond here, and please tell me if I make a mistake, because I could definitely done an algebraic mistake here or a number mistake. I don't think I did, but I could have. Um Anyways, this is a more decent question. Even maybe a little bit too what's the right word? Verbose with the coefficient. A lot of times I choose easier coefficient, very simplified coefficient that makes perfect beautiful like numbers because especially with these ODEs, they go insane if you choose like whack numbers. Um Anyways, you get this little equation over here. And now we got our G again. And then oh yeah, this is the proof over here. This is the proof I showed you. And it's more small, but you can see over here, you get a slightly different thing. You don't get the wool skin on the top. You get a Y2, Y1 with a negative over here. That's why I wanted to show this off because show the third one because I showed the general pattern, but the second order one actually breaks the pattern. And yeah, as you see, you could now you could look at the whole thing now. But the next one is interesting. This one is more fun because this uses the different guess. This is the first time we use a polynomial guess, which is different than the because we have different things here, and usually this goes to polar form. Honestly, this ODE is polar form usually. You use in polar sometimes. I've seen it before multiple times in polar form, and it's actually done by separation in in with the dash of what was it called again? God. Well, you basically have polar form in in yeah, basically using this. I'm blinking out here. I'm trying to remember right now. I cannot think. Um, yeah, but basically, you most likely have seen this in polar form, um, because this kind of like happens, Kashi's things in polar and not in this kind of time format. I maybe should have put R over here, 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 but I didn't want to. I was too lazy to do that, and you really see it in circular objects. But I did explain that it was in polar form usually. Uh, all the time, yeah. So yeah, I should probably change it to polar, but I didn't want to. So, because it would take some time, and I made a mistake of making it time first, and then I didn't want to change it at all. So that's what happened. Anyways, so on and so forth. This is the first time we do a different guess, and it actually works out because you see a plus and minus here. We have two solutions, therefore that must be the two solutions that governs the whole thing over here. And then this is the first time I actually showed you the wolf scheme because I have space over here because I didn't have to explain it anymore, um, and how to solve it. And then we integrate the private. Actually, we did solve a wolf scheme in the past over here, but yeah. So first one we have done ODE that looks off, but is solvable by a different polynomial. Now I need to look at Wolfram Alpha because the final answer I got insane answers. And I did not think there was a simplified answer, but apparently this and this is the same, according to Wolf Alpha. So yay, we have a simplified answer. Anyways, I was not about to do this, so I let the Wolfram Alpha handle the constants, but you can see kind of why it would be working in polar. You see that over here it goes to infinity and it kind of like feels like a disc shape over here, and over here, I don't know, but yeah, you could kind of see what's